Okay, let's just start tracking what we have here and then we can just implement some stuff. So let's see what we have on its status. So let's add our bin, fast jump spec, lib and spec. Oops, git. We can, oh, sorry, I forgot git add. So I can also use git add for guard file because I like it. To not be a big deal. So git commit -m. So introduce fast inline local variable. Let's make it more humanized. Okay, so now we have something tracked and we can just keep the track of our change. So one thing I thought about this initially is we got one more test here. So the current test is covering is very simple. So this is like a let's say simple extraction, and this is working. And if we try to introduce some more complex expression here, let's see what will happen. So let's say we will have some different code. So the code here will be a plus a, and we need to have exactly the same result. So it should inline our reference. So let's see if it works. Okay, it works. So we have some more complex expression and it's recursive working. So we can say here test case, and then we can start a new test case and see what else we can build next. So this was pretty simple. We can also keep adding more complex ones. So for example, complex expression. Let's say we wanted to cover like multiple references. So I will say a equal 1 and b equal 2, and then I will say a plus b, and this and then here I will have like 1 plus 2, right? So that's the case. So we can just test it and see. So yeah, it does not work. So we get to our first case that for some reason no expression was getting from it, and then it does not work. So we need to research and understand, and this is very hard because AST can be very exotic and have multiple problems. So that's the hard work we need to do for implementing these kind of tools. Let's start. So first thing, let's just get the code here, and we could just try to join here, and then we can start debugging our problem. Okay, so subject is the problem. So subject is not replacing anything because the current implementation is not working. So So here we have the code, and basically we are looking for local variable assignment and local variable assignment of some AST. So we're thinking about this. So basically our code is this one. Uh, this one, okay. So we can just try to understand what's going on here. So this is the first part we need to do. So we have the ST, and we have multiple local variable assignments, and here we have simple, and the simple returns what we want. So it returns both A and B. And what else we have here? We are doing this replacement. So for example, lvars here is just indexing different. So that was probably the problem, because oh no, it's okay. So let's take a look in this in more details, so we can start debugging it. So probably we have some weird issues around here, and for some reason it's not working properly. So let's try to see what we have here. I will just Control Z, and let's run only this single spec, because the previous also will touch that part. So here we are in the first part, and here we are in the second. So we have lvar node, and it's working. We are in usage, so the usage is lvar a, and basically we just use lvars, and lvars should index by some variable name, but I guess this is exactly the problem. So we are not indexing here. Yes, we are not indexing because lvars in somehow is not bringing this. So let's just see if we can see. For some reason we cannot see the entire code, so let's get sorry, it will not work. Let's get back here in the, so we passed multiple times here, and we were inside it, and the problem is that we have these incompatibilities in the node type, and then this become the issue. So we are trying to find a node, but the examples looks like they are different. So we are not able to index lvars here from this capture. Looks like they have a different result from the previous example. So I was wonder how the previous was working like this, but now I thought like we need to rework on this. So let's go for understanding this problem, and basically this is the old code, and the new code needs to just find the element. So let's say here we will have the implementation will be directed the lvar node. So I guess maybe this adverse is not needed since we have this. So the source here is advar node, right? Advar node block expression. So I guess this will work, and we don't need this at all. So I guess I solved the issue. So I was just getting confused because I decided to implement them independently, and then we just pick the right one here. So we don't need this. Just confirming? No. Okay. Let's see if it works. Okay, now we broke everything. So let's do exit here. Okay, so I was wrong. In this case, LVAR node is the entire node. That was the issue. Like we just pick the entire node, and we need to just put the children of this to make it work. So LVAR node, and here we can get children dot last, because this is the last, or it will just have one, and that is what was wrong. So if I do RSpec again, now I can do exit, and we got just choose and call. So yay, cool, we make it work. So let's just fix this on spec inline, line 26, and we can just remove binding try, put one more column here, and this is what we want. So cool. Let's see what we have on git diff. So we simplified a bit here. We don't need this anymore, and this, especially advars, was a crazy thing. So we have simplified a bit, and we can just say okay, so okay, just amending the message, and this is what we built until now. So now we could cover another kind of examples. So for example, let's say we can build something like instead of local variable, we can also pick local variable from arguments. I guess they are a bit different. I don't remember. So let's say, for example, method scope. Method scope not let's do not cover this for now, but let's say, for example, arguments in methods, for example. So what we have in arguments in methods? So we need to have a code like def a, and basically it receives b, and then I can just say for example, one. Let's do some column here. 1 plus b, and 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 basically no, in this case we need to have a usage, so this is a different case, like a method definition. So we could do that as well. So it's another case, another scenario, and everything new, and we will also allow us to practice more. So for example, um, let's say this is 1 plus b, so this method name can be plus 1. So let's have some real case number, and I can say number plus 1. So, and then I can have a test here, plus 1, and then I can have a usage of some number, so I have plus 1 in the number, and then what this code should become, it should become 1 plus 1. So this is not exactly inline a local variable, so it's inline a method. So something new, method def. Let's say method def because we have method on the object level. So let's do not mess with some object methods. So now I can say that this is in another context. So we have a describe here, and we can say def, and this is what we wanted to cover now. So how would you implement this? So let's take some minutes and let's continue thinking about this next case. So just to refresh the mind, so let's just open lib fast inline here. So let's use this, and basically we will have something similar but not equal this, and let's just build this as method def, and then you can just take a look here on what AST means. So we can prototype it entirely and just see what we need, and then we can implement it. So basically this is our start, and oops, looks like I break something on spec. I forgot the error. So line 37, we break the last end. Okay, so we have this context. I forgot to do here. Okay, so now if you run our spec here, you can check the AST, and you can see we have a def, we have a +1, and we have a few elements that we wanted to treat. So we understand that we have an args here, and we have a number, and this number is now a local variable. So it's a kind of similar, and it's just in a different scope. So in this way, if we find some argument that is also a local variable, we can just simplify the call. And this call is the call of the method definition. So we could get what the definition do and make it inline. If we wanted to make it simpler, we could do just like a method that returns something like, let's say, def1, and then we return 1, and then we have 1. Yeah, for some reason it does not work here, and I typed the one here, so it's crazy. But okay, so probably because the scope of the where I am, probably I am in the module and I am implementing method that should just be available new. And as I am a module, I don't have it. So this module should be included, or I need to be in a module function. So as I am in the instance, it will not work. But I guess you grasp what we can do and how we can make it so. Let's start with this simple case because we can start using def and then we can get more complex cases with the method definition. So let's switch our example first, and let's say this is our next thing. So let's put sheet here and just say sheet x here, and let's oh, I don't know if I have this as a plugin. I don't remember if it's inside, but probably we can just keep it breaking, and we can say method definition without arguments. So let's say one. So one is a method that returns one, very simple, and we can call one, and we will have just one in end. Inline method definition with the current expression, with the current method call. And that's what we wanted to build. And this is secondary, so we can just put like a begin here because it will be the next case, and we can just continue it later and see how it goes. So okay, so the AST now is pretty much simpler, and we can just imagine that after args we will have a body, and we can just pick any call for method definition, and it should be enough.